friends, in this video we are going to write a program for the 8051 microcontroller in the assembly language to generate the Fibonacci series for given n terms. Fibonacci series means, like, suppose if the first number is 0, next number is 1, then 0 and 1 they will be added and that will become the third number. Then second and third number will be added and that will become the fourth number. Then third and fourth will be added, that will become the fifth number. So in this way we have to generate the Fibonacci series. So let's start with our program. So let us first see the program statement. So the program statement is that, or our problem is that, we have to write a program in the assembly language of 8051 microcontroller. Means that we have to use the instructions from the instruction set of 8051 microcontroller. And then we will write the assembly language program with the help of that. And that program should be able to compute the Fibonacci series of n terms. So let us first see that what is a Fibonacci series. The Fibonacci series is, first term is 0, second term is 1. Then 0 and 1 they are added, means their sum is 0 plus 1, 1. That will become the third number. Then 1 and 1 they will be added, that will become the second term, that is 2. 1 plus 1, 2. Then 2 and 1 they are added, that will become 3. 3 plus 2 will become the next term 5. 5 plus 3 will become the next term 8. 8 plus 5 will become the next term 13. 13 plus 8 will become 21, that is the next term. So in this way the series will go on. So the series will come in the way 0, 1, 1, 2, 3, 5, 8, 13, 21. So that is the Fibonacci series. So if we want to write a program for this Fibonacci series to generate the Fibonacci series for the n given terms. So let us suppose that n here is equals to 10. Means after 10 values we want to generate the Fibonacci series. Now how we will generate it? Let's use that how we are going to plan our program. Okay, so first of all we will use the register R0. Now this register is initialized as the start of array, because in the memory of the microcontroller we have to generate this Fibonacci series. So from which memory location this Fibonacci series is going to start, so we have to provide that address of that memory location, that from this memory location the Fibonacci series of n terms is going to start or is going to stored in the memory of the microcontroller. So the starting address of the array, suppose that we are generating the Fibonacci series for 10 numbers, so the length of the array will be 10. Okay, that is also going to be provided in the program, that for 10 numbers you have to generate the Fibonacci series. Also where this Fibonacci series is going to stored in the memory, so starting address is to be provided. So R0 register is going to store that address. Okay, after that we will use two memory locations. Okay, at first memory location, from where the array is starting, at that we will store the number 0. Okay, at second memory location, we are going to store the number 1, because you can see that the Fibonacci series, the first two numbers, it has to be provided by the user to the microcontroller. Then only microcontroller is going to add them and then generate the Fibonacci series. So 0 and 1 is to be provided by the user. Okay, so we are going to store these two numbers at the first and the second memory location. Now at the third memory location, we will store the sum of these two, that is 0 and 1. We will add these two numbers and the result of that will be stored at the third memory location. Okay, after that, second and third memory location will be added and their result will be stored at the fourth memory location. Okay, next at the fifth memory location, third and fourth number will be added. So in this way, we are going to store the numbers at the memory location, starting memory location, starting address we have already provided. We have provided that you have to generate it up till 10 values. Okay, and first two terms also we have provided in the program. Okay, so this is how we will plan our program. Now let's see the flow chart for it. Now in the microcontroller, the Fibonacci series will not be generated in this binary format. It will be generated in this decimal format. It will be generated in hex. That is in hexadecimal format. So in hexadecimal format, here we are having 0, 1, 1, 2, 3, 5, 8, 13, 21. So it will be like 1, 1, 2, 3, 5, 8, 0D, 15, 22 in this way. So now we have planned that how we are going to run a program, how we are going to generate the Fibonacci series. Now let's draw the flow chart for it. Okay. So with the help of the flow chart, we will be able to see that what will be the direction of flow of the data, how the instructions are going to be written, what will be the sequence of instructions in the program. So in the flow chart, the first block is the start block, which is shown in the oval shape. Okay. After that, we have to initialize all the pointers. Okay, one pointer is for that we are counting the 10 numbers. Okay, one counter will be that. Another pointer, that is memory pointer, because we have given in the R0 register the starting memory location. So to come to the next memory location, we have to use a memory pointer that is going to point towards the 10 memory locations of this array. Okay, and counter for counting the 10 numbers. So first step is we will initialize the register R2 as the counter. Means it is going to count that you have to generate Fibonacci series for 10 terms only. After that, we will initialize the R0 register as the starting memory location. Okay. Now, because we want to generate the Fibonacci series, so first two terms, that is 0 and 1, they have to be stored in the memory location. So first step will be to store the first term, that is 0. After that, we will increment the memory pointer so that it can come to the second memory location. So memory pointer is what? R0. So R0 will be incremented so that it can come to the next memory location. Now at next memory location, we will store the second term, that is 1. After that, we have to compute the next term. So we have to add these two. Okay. So next step is to compute the next term. What we will do, we will use the addition instruction of the microcontroller to add these two numbers. Now when we have calculated that addition, we have done that addition, we will store that result at location R0. Okay. After that, we will increment the memory pointer. Now how the next term will be computed? Next term will be R0 minus 2. That means the location at which the R0 register is pointing, we have to subtract 2 from it. We have to decrement it by 2 plus the at the position where R0 is at present minus 1. Okay. So like second and third memory location will be added, third and fourth memory location will be added, fourth and fifth memory location will be added. So in this way you have to compute the next term. After that, store the result to location R0. Increment R0 to next memory location. Now when you have stored the next number, then you have to decrement the counter because the number you have generated, you have to generate the series up till 10 terms only. So every time you have to decrement that counter, that this much terms are already being generated. Now the remaining terms are like 9 terms are to be generated, 8, 7, 6, 5. And when this counter becomes 0, then this procedure has to be stopped. So next is to decrement the counter and when you have decremented the counter, you have to check that whether this counter has become 0 or not. So this is a decision unit, okay, and this is shown in a diamond shape. So here you have to check that is the count equals to 0 or not. Now if it is 0, then display the result, display the Fibonacci series of 10 terms and stop the process. Stop is again shown in the oval shape. So here the program will stop. Now if the counter is not 0, you have to again repeat the process. You have to again compute the next term, add them and store it. So the process is to be repeated from this step. That is compute the next term. So after this step, if count is not 0, then come to this step, again repeat all these procedures and then again check that whether the count is 0 or not. If it is 0, when it becomes 0, you have got the Fibonacci series of n terms, display that series and end the program. So this flow chart shows us that how the instructions or how the program is going to run. Now, to write the program, what we will do, we will replace all these blocks with the instructions of 8051 microcontroller. The steps will be same, the sequence will remain the same, just we will replace these blocks by the instructions. So let's write the program. So in our flow chart, our first step was to initialize the counter. That is because we have to generate Fibonacci series for 10 numbers. So this 10 number value is to be provided to the microcontroller. So first step is to initialize the counter, and we are using the register R2 as the counter. So in that register, we are going to move the immediate value 10. Now 10 in hexadecimal is written as 0A, and H denotes that this number is in hexadecimal format. And because this is the direct data, so an asterisk sign, this sign is used to represent that you have to move this data directly into the register R2. So the register R2 is now going to contain the value 10, that is 0A. Okay. So immediate addressing is used because immediate data, the data or the operand is provided in the instruction itself. And whenever we want to store or move any in that register, if we want to move any data, or if in a memory location we want to move any data, then we use the instruction move. This instruction copies that data into the register. Okay. Now next we have to initialize a memory pointer. Okay, and we are using the R0 register as the memory pointer, because if we want to generate the Fibonacci series, then that series is to be stored in the memory at some memory location. So starting address of that memory location, that from this memory location the series is going to start. You can see your result from this memory location. So that is to be provided in the program. So next step is move R0 25H. So 25H is the address of the memory location from where the series is starting. So again in the R0 register, we will get the address 25H. H is again for hexadecimal notation. This is for the immediate addressing, and this data is directly moved or copied into the R0 register. Okay. Now next step, we have to, in the flowchart we have seen that we have to provide the first two terms, that is 0 and 1 in the program. Okay. So first two steps from the flowchart we have already done. We have initialized our register R2 as the counter equals to 10. We have initialized the R0 register as the starting address of array. Now we have to store the first term, that is 0. So what we will do at this, we will use two registers A and B. In A register, we will store the first term 00. In second register, we will store the second term 01. So in A we are having 00, in B we are having 01. Now these two numbers are to be stored at the 25, 26, 27, 28, 29, to A, to B, to C, to D, to E, to F. In this way the memory locations will go on. Okay. So here 25, 26, 27, 28, 29, at these memory locations we will have, at 25 we have 00, at 26 we want 01. Okay. So what we will do at this memory location, that is the number which is in the R0 register. So we will use indirect addressing R0. What we have to move? The data which is in the accumulator, that is A. Then we will increment the R0. Now R0 will become 26. At this memory location, we have to store the register contents B. So again move the number which is in R0, the contents of register B. Again increment R0. So what these steps are going to do, in A or B we are having these contents. In R0 we are having the address 25. So at 25 a number is there, the number which is in A, that is 00, that is to be stored. Increment R0, so now R0 will become 26. 25 plus 1, it will become 26. Now the number which is in register B, that is to be stored at the memory location which is in R0, that is at 26. So at 2601 will be stored. This sign is used for the indirect addressing. So after incrementing R0, it is now, because first the R0 is at the 25 memory location. When we have incremented it, its value has become 26. And now after shifting the B component into the R0, that is at 26 memory location, it is again incremented. So now R0 is having 27. Now next our step is to add these two numbers and store the result of this addition at the next memory location 27. So now because R0 is at 27 memory location, so we have to decrement it by 2 so that it can reach to again at the memory location 25. So next instruction after this is, because we have to decrement the R0 register by 2, so we will write the decrement instruction 2 times. So now R0 register is carrying the memory location address 25. Now at 25 memory location we are having our first number 00. At 26 we are having our next number 01. So we want to add these two numbers. So what we will do, we will again shift the number which is at this 25 memory location into the A register and the number which is at 26 memory location into B register. So next instruction will be move A, because we want that number in the accumulator. So we are writing move A, comma, indirect addressing, because that address which is in the register R0, at that address we are having the data. So indirect addressing is used. So now A will have the contents 00. Okay. Now we will come to next memory location. So we will again increment R0. So now R0 will carry 26. Now at 26 we are having second number, so we will shift this number into the B register. So next instruction will be move B, comma, indirect addressing again. Okay. So now in A and B register we are having the two numbers again. First we have shifted these numbers. In A and B register we have loaded, we have initialized our Fibonacci series, that first two numbers will be this. Now we have put these two numbers at the first two memory locations of the array where we want to generate the Fibonacci series. Now again we are shifting these two numbers into A and B register so that we can add these two. Okay. Now next instruction will be, again we will increment our R0. So INC R0. So now R0 will be having 27. Because at 27 we want to store the result of the addition of these two numbers, that is 00 plus 01. So next instruction will be addition, add A, comma B. The A and B registers, they will be added. So after their addition, the result will be stored in the A register. So 00 plus 01 will be 01. Okay. Now in accumulator we are having the result and we want to store this result at the next memory location. So our next instruction will be move the address which is in R0. So again indirect addressing. And what we want to store? The number which is in accumulator. So accumulator is our source and R0, the address in R0 is our destination. So at 27 we will be having the next number 01. So after this again we will decrement R0. So again R0 will come at 26 memory location. Now because we have generated our third number, so we have to decrement the counter because R2 register which is initialized that we want to generate the Fibonacci series up till 10 numbers. So because one number we have generated here already, so now we have to decrement the counter. So next instruction will be decrement the R2 register. Now, because only 10 numbers of the Fibonacci series are to be generated, so these process, the addition and storage of the data, it is going to repeat for 10 times up till this counter, that is R2 register, which is initialized by the value 10, it should become 0. So next instruction is decrement. After that, compare this register R2 that whether this register is equal to the immediate data 00H. CJNE is the instruction compare and jump when not equal to. When it is equal to, then it is just going to end the program. And if it is not equal to 0, means the counter is not 0, then we have to repeat the process. So it is going to jump at a memory location up. Now this up is written at the address. Again the R in the R0 register it is 26. So 26 at this memory location, whatever number is there, that is to be shifted in accumulator. So again the process is to be repeated from this instruction. In R0 means 26. So at 26 we are having 01. So in accumulator 01 will come. Increment the R0. R0 will now become 27. At 27, whatever number is there, move it in the B register. So at 27, we are having 01. So in B register, we will have 01. Again, add A and B. The result will be in A. So 01 and 02. 01 will become 02. So whatever is in A, move that in R0. R0 is incremented here. So now R0 has become 28. So accumulator will be stored at the 28 memory location, that is 0, 2. Again decrement R0. R0 is decremented. R0 will become 27. R2 register will be decremented. It will now become 8. Again 8 is not equal to 0, 0. So again the steps will be repeated. And when this R2 register has become 0, it means the 10 numbers, the Fibonacci series of 10 numbers is being generated. So in this way, using the instructions of the 8051 microcontroller assembly language, we can write the program to generate the Fibonacci series for given n terms. If we want to generate the Fibonacci series for 20 numbers, we can initialize this register by 20. Okay, so up till 20 numbers Fibonacci series will be generated. So to generate Fibonacci series for given n terms, we can write this program. Let's summarize it what we have done it, because we know that in Fibonacci series it is like The first two numbers are 0 and 1. These two numbers are added, that will become the third number. Then second and third number are added, it will become fourth number. Third and fourth will be added, it will become fifth number. So 0, 1, 1, 2, 3, 5, 8, 13, 12. In this way, Fibonacci series is generated. So we have given these two numbers 0 and 1 in the program itself. You can see in the program we have provided the microcontroller 00 and 01, the first two numbers of the Fibonacci series. After that, because we want to generate Fibonacci series for 10 numbers, we have used a counter, and we want that this series should be stored in the memory location from the 25 memory location. That is 25 is the address of that memory location. So that we have provided. Now we have incremented the R0 register. We have stored those numbers at the first two memory location. After that, we have added it and stored the result. And in this way, all the processes repeated up till the counter has become 0 in the last, and 10 numbers Fibonacci series is generated. So we have written the program for the 8051 microcontroller using its assembly language, its instructions to generate the Fibonacci series. So I hope that this program is now clear to you. Thank you.